the next talk that we have on track 1 for you is called Thinking in Types. And I must admit, I was definitely intrigued by that description, because it seems like so many people, when they talk about types, seem to see types as some kind of angry schoolmaster that hits you around the wrist when you make a mistake, and and kind of it's something that is working against you. But when I see the description from Kjeld Schmidt's talk, what I see is someone who's really thinking about how types can be your friend, can help you frame problems, can help you think through problems, and can help you get to cleaner and more robust solutions. So Kjeld Schmidt, the floor is yours. Your talk of Thinking in Types starts now.
Thank you very much. Thank you also for being here, and also for the great introduction that already covered in detail what I'm going to talk about. So just to set some expectations, I am going to talk at a fairly low level, just really talk about the friendly side of types. I'm not going to go deep into functional programming in Haskell or anything. This talk is for you if you are working in JavaScript, Python, PHP, if you're interested in getting more support from your tools, more automated checks against your codes. Maybe if you've recently struggled with a null pointer exceptions, some undefined values, and you had trouble debugging this might be interesting for you. And just for some context, I am wearing a black t-shirt, I have dark short hair, and I'm joining from Cologne from Germany in the Cologne office today. So first things first, what are types? What do I mean when I talk about types? And basically, when we've worked with programming languages, we've all seen them before. Very basic examples include things such as Booleans, numbers, strings. So the type Boolean can have 2 possible values, true and false. The number type can have many different values, all of which represent some kind of number. We have more complex types, like the string array is a different thing from the string as far as types are concerned. The string list is a different thing yet again. They behave similarly in many ways to the string array, but they have different operations and are therefore of a different type. We can have more complex types like dictionaries that depend on other types, and we can define our own types through classes, interfaces, and many other constructs in various programming languages. As a more general concept, types also show up in things like files. So an MP3 file is a different type of file than a JPEG file. You wouldn't be able to upload it as your profile picture on social media. When you're working with an API and the API server expects the request to be sent as a JSON object, then you can't send XML. You might convert between those 2 types of data systems, but they won't be quite the same thing. As an even more generic example, this can even come up with in basic human conversation. Say you've gotten vaccinated recently and you're able to meet friends at the house again, and they ask you, what would you like to drink? Then you probably shouldn't answer yes, because the type of question that they asked didn't expect a Boolean answer. They expected a drink, not a truth value. So that's just the basic overview. And types essentially form a contract. They define how types interact with operations and with themselves. The input and output of functions are given as a type, and so the entire function has a type that is defined by the inputs and outputs. So as a basic example, when you add 2 integers, you will always get another integer back. When you multiply them, you will always get an integer result from the multiplication. When you take an int and a decimal, say a float or a double, and divide those, you will always get that decimal type back. That is a possible implementation that depends on the language. And this kind of type interaction can be encoded as a type signature. So the addition operation could be defined by the 2 input types that are both integers and the return type that is an integer. The length operation could take a string or a list or an array and return an integer. But this length operation that we define right here is taking in a string and returns an array. So this is a kind of guarantee that the type is supposed to give to you. Types are not quite the same thing as classes or interfaces or structs. All of those define types, but for example, classes also contain the implementation, which the type doesn't care about. The type only cares about the input and output, the kinds of values that are given, not the exact values. So all of those describe the type, but they aren't quite the same concept. In fact, while we're on the topic of conceptual distinctions, what I've told about so far has been mostly a mathematical, idealistic description of what types can be. When we actually develop something, when we write code, then we are using a specific language, and various programming languages have different approaches to how they actually implement types within them, to how you as a developer, as a user, should interact with their type system. And there are many nuances here, but I want to just go over the two most important differences that you will very frequently see. So the first one is the difference between static typing and dynamic typing. In a statically typed language, you have to declare the type of all of your variables, functions, methods, and the language will make sure that you are held accountable to this type declaration. So in Java, for example, you could declare a variable of the integer type and assign an integer value. And later you could reassign it to contain a different integer value, but you will not be able to assign a string value to it or Boolean or anything else. Only integers can go into this variable, and the compiler will make sure that this is true. This is in opposition to dynamically typed languages, such as Python, JavaScript, many others. We just declare a variable by assigning some value to a string, to a named variable. You don't even have to declare it ahead of time. In some languages you can or you have to, but this is valid in both Python and JavaScript. You can just declare a variable, assign a different value of the same type, but you can also assign a different value of a different type. This is allowed, while this is not. This just depends on the language, and you don't really have much control over this aside from choosing the language or possibly a framework. The second major difference is strict typing versus weak typing, which might seem very similar at first glance, but it's actually reasonably different. The difference here is that strictly typed languages will actually still care more about the type itself than weakly typed languages, and they will not do any conversions for you, even if those seem reasonable. So as the example here, I have a square method that takes in any given number and calculates the square of that number for both Python and JavaScript, both of which are dynamic languages. But if we try to do this in Python, we can have an actual integer and put that into the method, and we will get an integer back. If we try to put a string into it, which very clearly represents an integer value in a way that would be convertible, we will still get a runtime error, and the runtime will tell us this input was of the incorrect type. We would be able to explicitly convert the string into an integer, but we have to be explicit that this is what we want to do. This is not true in JavaScript, where we can use the same string, and when we put that into a situation where a number would be needed, then the JavaScript runtime realizes, oh, this is a string. I can't use it directly. I'm supposed to perform a calculation on a number. So let's just inspect the string and see if maybe I can get a number out of this. So in this way, the weakly typed language will give you some more freedom to not have to worry so much. but it will be less strict in accepting all numbers and no strings. Rather, it will accept all numbers and some strings. It will leave some wiggle room here in the terms of what types it accepts. The important thing is that neither of those is necessarily better than the other. Strictly typed languages give you more guarantees than dynamically typed languages ahead of time, but dynamic languages give you more freedom to express your thoughts without having to introduce many distinct variables, without having to think quite as much about it. So it might lead to shorter and more readable code potentially. Similarly, strong languages will give you some guarantees about checking the types for you. But if you know that they're fine, then the dynamic language will just deal with it when you tell it to just deal with it. So how does it help to use types? Well, basically, I am going to argue that, although I very explicitly say and truly believe that neither paradigm is superior, I also very strongly believe that considering types, at least on a mental level, as part of your mental model, will lead to cleaner and more stable code. Because if you think about what kinds of values can go into your methods and functions and operations, you will be able to more clearly consider which would be what edge cases you might run up against and how you might make sure that all inputs are accepted and you don't run into any runtime errors. So one example would be that some methods are just not able to deal with all possible inputs depending on how you write them. You can easily construct such a thing by just having an if check for a certain number of values, and if the input isn't that value, then you can throw an error. But more importantly, this can happen by accident quite a lot. So here we have a Java example, and we just have a method that for some reason takes a string as input and returns the length of the string as output. Now, the length method is defined on the class string, and if we have an empty string, we will get a 0. If we have a longer string, we will get the number of characters in that string, and everything is fine. Unfortunately, the string type in Java, like all reference types in Java, can also hold a null value, which is a different thing from an empty string. And when we try to call the length method on the null object, then we will actually get a runtime error. Our entire application will crash and come down. And the only thing we'll have then is a stack trace. Obviously, this is something we want to avoid, and we want to deal with this explicitly in our code. There are many, many different ways to approach this, and it all depends on the exact context on what you're doing. But I want to explore one small example where we can kind of see the difference between approaches, between fixing the problem and making the problem go away permanently. So here we have a very similar setup as the previous, much smaller example. We have a method that takes a string as input, and we call that method from some completely different point in the code. So what we do here is we have a list of values, and we want to check if the given value is in that list. So far, no worries. However, there's a small, I want to say, quirk in the Java language that makes it so that if you create a list with the list of method, then this particular kind of list you get back there will actually fail if the contains method gets a null value as input. And it will be possible in our case that the input is null. So that might potentially lead to errors, which obviously we want to avoid. We want to avoid those runtime errors that crash our application. So what could we do? Well, if we're not allowed to put a null string in here, then we could just have a null check before that. We only get a Boolean back out of this method anyway, and we can decide that if the user input string is null, then we don't even need to check the other part. It's fine. And that works. At this point, we don't have a runtime error anymore in this specific situation. However, calling this method in this way is only safe after the null check. And if we do it like this, we put the null check in front of the method call, then we will be safe here, but we will always have to remember to do the null check in any other place where we do that, where we call that method again. So not only do we have to do the null check everywhere, we have to remember to do the null check everywhere. And that could easily be forgotten by myself if I do it repeatedly, but it could be forgotten by other people who just aren't aware of the issue that might arise here. So a different approach we could take is to put the null check into the method itself. Because if we do this in this particular case, we can easily say, oh, if the tool name is null, then we don't even need to know, and we don't even need to check the list, it's not in there. And we can very generally say that this should always be the case. This is just sensible domain modeling in this case. Now, this won't be quite as easy yet in all cases, but in this case, we have now completed the method in such a way that any value that the compiler will allow to go into this method will be guaranteed to be safe, will be guaranteed to not throw a runtime exception and to not crash the application. So in this way, in this context, while both approaches lead to the same result, a method that doesn't crash, this one is much more maintainable and safer for the future, because if you do it this way, you can be certain that you will not run into any other issues again, and you won't have to have the check here. So that's good and fine and all, but what if the language doesn't support types quite as explicitly? What if there is no compiler to check the input that we are given? Well, in that case, we can still apply a mental model of what data do I need to achieve the goal that I currently have? What type of data do I need? And take a step back from being really deep in the code and seeing what's available in the current situation, and instead trying to force yourself to think about what do I need, and only after you decide that, think about how you can get it, if it is available or if you have to convert it. So I want to go into another example in really quite excessive detail to explore an issue that actually came up in one of my previous projects, where we kind of made an error that beautifully illustrates how typing could have helped there. And basically our problem had been the following. If you've seen the talk by Amy earlier, she used a very similar example. So we had a user sign-up form. We had a couple of fields. Some of those fields we wanted to verify. For example, we wanted to make sure that the password was safe and that the email at least appeared to be a valid email. So how did we achieve this validation that we wanted to happen before the code ever submitted? Well, basically, we had this submit handler that would run whenever we click the submit button. And it would only check if the current state of the form contains any errors. And if not, then we would submit the form, do the API call, register the user, as long as the backend is also fine with everything. And the actual checking to see if errors occur happens in this blur form handler. So what we wanted to do was, if you start typing your email, it shouldn't immediately tell you this isn't a valid email, because maybe you're just not done yet. So we only want to run this afterwards. So that's why it's a blur handler. It only runs when the focus is lost. When this happens, we put in the input element itself. And the first thing we do is we verify that the value given to this input is correct, conforms to our standards. And whatever the results of this method, we would put it into this variable. It could be an empty result if the method is fine, if the input is fine and valid. Or it could be a string describing an error message, like, oh, this email doesn't look correct. Oh, this password is too weak. Whatever it was, we would then show this right next to the form using this method. If there had been an error before, the user had typed something new, and now the error is gone, this would also take care of removing the old errors. Now, after this is done, we are not quite able to set this value yet, because if we just say, oh, the most recent input that we checked was valid, then that doesn't give us information about the entirety of the form errors. So what we did instead was we also verified the entire form at once. And then only depending on the input of that form, output of that method, would we actually set the form error state variable. Undefined if the form was fine, there weren't any form errors, or if there was a form error, then we would put in the error variable that we got above. Now, here's where the bug is coming in, because the error variable is a string if there is an error, but it can be undefined if this particular input happens to not have an error. So what could happen in some cases is we would verify the entire form, see that it is not valid, and then down here, when the most recent form we have, form input we have checked would happen to be fine, then we would input undefined here, the same as we did in the other branch. And in that case, the form would actually submit and try to create a user with invalid input. Our backend verification would prevent this, and the user would be presented with a server error. Now, what we did then was, well, we have to investigate this and fix this. I kind of spoiled already what happened there. So what we did to refactor the code was to look at, hey, where are those form errors even used? What are those used for? And we realized those form error variables, this form error state variable is not used in any other place of the component. It is only set here and only read over here. So realistically, the actual value of the string that goes in here never really matters. So the first thing we did was to just put a static string in it, because, well, if this had an error, then we would get a string here, and this would prevent the form from submitting. Now, this is not terribly nice code. We have a static string with some value that doesn't matter as one option for the form errors, and the only other option would be an undefined value. So we thought about it for just a little bit and realized, well, it's just two possible values that should be a Boolean. We could refactor after realizing that the Boolean has all the expressiveness we needed. And this is already much nicer from a type perspective. We now have a clearly defined form has errors attribute. We also renamed it to more clearly reflect what it actually says. And we only set very specific values. We know exactly what's going on because we know exactly what's needed for this. And at this point, we looked at it and realized, okay, we really only checked the verify form. In the true case, we just set a false. In the false case, we just set a true. Oh, this can actually be refactored into a much nicer state. We could actually remove the entire thing and just verify on submit. This would actually get called less because most users would type into several fields, but only click the submit button once. So here we could have realized ahead of time that, well, maybe the verify input doesn't really give us the exact type of information we need to to verify that the form itself can be submitted, but we didn't. And the language didn't tell us ahead of time that there was something to be concerned about. It didn't warn us to take care. So would that have gone differently if we had more support from the language? And I would argue yes. And to argue that, I would like to show you how the same code that we started out with could have developed and would have gotten tool support if we had used TypeScript instead, a superset of JavaScript, which gives a lot of support for types and some other operations, but mostly just puts a stricter type system on top of JavaScript. So assume we are starting with the exact same code that we had before. This is still completely valid TypeScript, mostly valid TypeScript. But now the compiler will actually inform us that some best practices aren't necessarily being handled by us correctly. So the first thing it complains about is, this form errors. What is that? I don't know that. To be fair, the error message itself is not the most helpful, but we've been using React for a while, so we know, oh, we have to declare the state type of the entire component. So we just say form errors, it's whatever, it's the any value allows you to just not specify what something is because you just don't care. Except then the linter, another tool, gets angry again. It tells us, oh, maybe don't use any because it's not very nice, is it? Just think about what you're doing there. And so the linter would actually also be angry at us, and we'd have to think, okay, we could try to work around this, but why not code this? Why not do this properly? Tell the tool what it wants to know, and then we would be forced to think about, okay, what is that form errors actually? Where do we use it, and how do we use it? And we could realize, well, we're really only using the value in this one Boolean check. So it probably should be a Boolean value. And then we could refactor it, get the same result that we had before, of the Boolean here. And now we didn't change the values we put in here, not yet, but immediately the compiler will complain about this. Oh, undefined is not value for Boolean. The string or undefined that we get here, that's not a Boolean. So we changed that as before. And as before, we could have made the realization, oh, actually, hold on, we don't really need this. And we could simplify the state itself again. Now, fair, you might not be convinced. What if we didn't have that insight that it should have been a Boolean? Well, it could have gone differently. We could have said, oh, this any, we still want to replace it, but we're just going to replace it by whatever we put into it. Here we would make the mistake of thinking about what data we happen to put into it rather than how we would use the data. That's it feels like a very small difference, but it's actually super helpful to think only about the uses of your data and never where it comes from until you are very clear about how you want to use it. But we are making this mistake now. We are saying, oh, the form errors, whatever we put into it. And I happen to know that what we put into it is either a string or undefined. TypeScript actually has the nice property that types are generally not nullable, and you can't assign null or undefined into them unless you explicitly allow this by having this kind of union type, this or type. So we could do this, and then it would say, oh, it might be null in this conditional. Please handle this explicitly. And we would say, oh, yeah, that's reasonable. Think about it again. And, oh, we only set the undefined if the verify form fails, succeeds. So it should not be undefined. And so we can do this check, and this would now completely satisfy the compiler and the linter. Neither one would still complain, but we wouldn't actually have fixed our bug. So that's kind of a sad case. the type system doesn't handle everything for you. You can still make logic errors, mental errors, approach things from the wrong side. But the final case we're going to talk about now is, wait, where did we get that type from? When I said, oh, this should be string or undefined, how did I know that? Well, I made the mistake of trying to see what I assign here, but I jumped ahead a bit in the logic. What I would actually do if I try to figure out what I put in here is to see whatever type I happen to have here in this variable. And then also think, yeah, or undefined. I have to have that undefined value possibility there. And when I do this, I would investigate, oh, what is that? Check the output type of verify input, which is defined somewhere else. I can just look at the type signature of the verify input method and see, oh, it's a string or undefined. And then I'll add the or undefined here. This should trigger a reaction that you say, oh, wait, this can be undefined already. So this is not clearly a distinction that's going on here. And this again should probably, hopefully force you into a situation where you think about what is going on with the data that I have here. What do I want to achieve? How can I be sure that what I want to achieve is possible with the things that I do? So, very long example, I know. Let's wrap it all up. Just quickly summarize what I've been talking about so far. Not so far. This next slide will be my last one, and then there will be the break. So basically, the important takeaways here are types can help you as part of your testing strategy, because types can be used to check entire classes of inputs and outputs, which in a completely untyped, unsafe language, you might have to do manually. They can help for automated analysis, because compilers, linters, static analysis tools, all of those can look at the types that you describe and see if there's anything weird going on. And thus they can nudge you in the right direction while developing your applications. Typing is often optionally available, even in generally untyped languages. So if you use JavaScript, you could try to include TypeScript in the project. You can use both in parallel and slowly start introducing TypeScript throughout your code base. If you use Python, you can either use the optional typing that is now part of the standard language, or you can use the even stronger MyPy package, which does even more checking for you, but in return requires some more work from you. Typing tools will not think for you. If you use a typed language, it will not prevent all errors you can make just because you have types going on. Many languages have their own little quirks, like Java. The Java nullable types leads to many issues. In quite generally, null and empty values like null and void and none will often force you to consider special cases just because the language has been set up in such a way that you won't get help there. This is slowly starting to change. For example, recent versions of C# actually use non-nullable types by default, same as TypeScript, same as Kotlin. If you're in the Java world, you might want to look into using Kotlin and Java at the same time, because Kotlin has many interesting improvements, but it's also quite different. Takeaway, they will not do the thinking for you, but they will force you to think, ideally. And most importantly, and this is the main point and kind of leads back to Chris's intro, the types are something that the computer, the runtime, will always know about and will always consider. And if you get it wrong, it will yell at you. But if you use a language where you are forced to consider types, or are just using types as part of your mental model, then you are at least explicit about what's going on, and you might have better chances of not getting yelled at by the computer. And that's just a surface level intro to all the many things I would want to talk about here. I've cut so much from this. I hope it's been interesting. Thank you so much for being here, and have a wonderful XConf for the remainder of the day.
Cool. Before you run away, though, Kjeld, I've got a couple of questions to ask you.
Yes.
So no more prepared. So do you want to stop sharing so people can see us more clearly? Cool. So I really like the way that you kind of led with thinking. Well, obviously the title of your talk, but thinking in terms of the types of an area. I guess the message I took away was kind of if the types I'm using are ugly, possibly the modeling I'm using is not clear enough. And that example you showed with JavaScript was clear. I actually had I know you spent a long time on the example, but I actually had a question I wanted to ask about yet another refinement. So you use Booleans for whether or not there are errors. One thing that people talk about is Boolean blindness, the fact that true and false are used in so many contexts that actually it's sometimes easy to miss out a not sign with the exclamation mark or flip to around. Did you consider using like an enumeration type or something so that to refer to like there being errors or not, or do you think that would be kind of overkill in that situation?
That's a really interesting question. So generally, I agree with the sentiment of using Boolean, of overly relying on Booleans.
Yeah.
I think the question I would ask myself in that situation is, do I happen to have two values here that just happen to be two possible values, but conceptually there's no limit to them being three different values? And in that case, I would trend towards using an enumeration. In this specific case, I would be quite happy having a Boolean because in the end, I'm just deciding, is this form valid? That is inherently a Boolean question, I would say. Yeah, but I absolutely agree. Not everything that has just two possible states should be a Boolean.
I guess like what you're pointing here is that it's authentic, that it's a yes/no question.
Yes.
And so the modeling looks kind of natural. It's almost like not a mathematical question, but a domain question of is true a intuitive and accurate way to represent that value.
Absolutely, and I think that quite strongly hits it again. Like, think about what's actually going on. Think about how would you talk about the data that is there. If you don't have a specific value, but you're just talking about the data flow, what is the type of data that's flowing?
Makes sense. So I'm going to ask a negatively framed question now, which is, is there anything that using types prevents you from doing?
I mean,
do they limit you?
I mean, yes, absolutely. So if you do use types, if you do have a compiler that forces you to think about types, then you lose some ability to do things in a given way. Generally, you will still have the ability to achieve everything with your code that you achieved before, but you're limiting the ways how you can do it. I would argue that this tends to be a good thing, depending on the application. So just for context, I very much use Python in my daily work, and I don't always use strict types. Not in my daily work, sorry, when I'm working on my own projects. I am much less strict about using clear type systems, about using all of the tools that I've mentioned here. But that is because those are very small projects where I'm the only one working on them. And also they are very small and I can keep the entire thing in my head. And I think the benefit of limiting yourself with types is that you are forced to think in certain ways that are more easily followable and understandable by the people you work with, and that scale when the program becomes larger. I think this actually kind of strongly relates to some other ways in which we as developers have generally agreed to limit ourselves. For example, we try like hell to avoid global variables.
Yeah. We
don't even talk about not using gotos anymore because nobody's even taught to use gotos in the first place. And I think this is a very similar thing, that a language where you don't have any type support is giving you so many ways to shoot yourself in the foot that you don't even want the ability to have that in large projects.
I guess ironically, it seems like a really good example of following the Python convention of explicit is better than implicit, right? You actually, if you're using types to model what you're doing, you're being clear about your intention for, like you say, your colleagues.
Absolutely true, yeah.
So I have a really, really important question to ask you, actually, which is, so at the end of the day, I'm going to be writing some closure without types, even though there is a typed extension. Mm-hmm. If it crashes visibly and humiliatingly in a way that would have been caught by a type system, right, are you going to tell me I told you so?
Put me right on the spot.
Sounds like you are, because if you weren't, that would have been an easy question.
I wouldn't be happy about it.
Okay.
But I think I would be investigating this, and I might be saying, hey, you know, it happened. Maybe we can prevent it like this. Like, right, full disclosure, the initial draft for this idea actually kind of happened because I got angry at JavaScript. So that's where I got the idea from. Yeah.
Absolutely. Yeah. When things break in public ways, it's definitely like an embarrassing kind of thing. And it has happened to me in the past. So like the null pointer exceptions you mentioned, you may very well see null pointer exceptions later on today. So let's ask a controversial one, right? Which is that there are two statements I hear sometimes, and I'm going to ask you if you agree with one or both of them. If you have good enough types, you don't need unit tests. If you have good enough unit tests, you don't need types. Do you agree with either of those or both?
First one is easy, no. I feel like types are really at a lower level than unit tests in a way. Yeah. They can, or like maybe go along the side of it. They definitely don't replace unit tests in any way, because unit tests also, they test what exactly is going on. They test the implementation to a certain degree. Or, right, I mean, not the implementation, but you know what I mean. There is a certain behavior we expect. When we have, like going back to the mathy definition, when we have the addition operation, the plus operation, we put two integers in, we get one integer out. When we actually internally perform a multiplication, then this will be confirmed to the type, and our type system won't catch the logic error there. Right. So that's easy, no. Can complete unit tests replace types? Yes, but I would say that it is much more work to really cover all of the cases with unit tests than it would be to cover all of the invalid inputs and invalid output types. All of that can be caught in unit tests, but you could just have that as types much easier.
Yeah, and I think like your point earlier about types kind of scaling is a good one there as well, that maybe there's a combination of your individual units that your unit tests don't make obvious, whereas types kind of, because they're automated, do naturally scale to plugging together bits across a code base.
Yeah, and I feel like this is really the main part. Things happen automatically. And if you, this is also why I really loved Amy's talk earlier.
Yeah.
The state changes, all of them get covered automatically, and you don't have to think about all of them. The system will tell you, oh, is everything covered?
Cool. So if you're convinced by this talk and you want to get started, I guess you mentioned a few things, but do you have any particular strategies or suggestions if you want to start using types when maybe you have a large code base or something like that?
That depends completely on how your code base is structured, what languages you are using. But most systems I know of have some kind of optional typing modules. Like Python has, I think it's PEP 484, or the MyPy package. JavaScript has Typescript, which you can integrate into a new system. PHP has the strict mode, and I think also another package for even more features. And most languages and systems will have something to allow you to start gradually introducing that into your code base. So maybe just Google whatever language you're using, types, and you might find something.
Sure. And I think the other thing I would do based on watching your talk is you can do the thinking about what values you expect at various points and clarify your thinking, even at a stage before you work out how to plug in that gradual typing library. And that's definitely
absolutely
one of the takeaways I got from your talk today.
Yeah, so one of the things I did in Python before I started really using the optional typing modules themselves is use explicit doc strings, which still have some amount of compiler support, and just it would check which inputs are there and verify that I've covered all of them, and then I would just write down the type. It's not quite as good as the proper typing modules, but it's a start, and it doesn't require as much investment.
Cool. Sorry, I just lost the sound for a second. So
no worries.
Yeah.
Sorry?
Can you hear me? Cool.
Yes.
Cool. Sorry. I guess the headphone software must not have used explicit types. Cool. Thank you very much, everyone. I should also say thank you for the efforts of the translator and the stenographer, because like having to translate all this stuff about very specific code terms while we're doing code heavy talks like Kjeld's excellent one, really freaking hard. And
I highly
very
appreciate
thankful
it
for all the effort you've done in that. We have a slightly longer break now. It's not really lunchtime, but it's aiming to give people a little bit more breathing room to step away from the computer. So the next talk in the afternoon, both on track 1 and track 2, will be at 1/2 the hour. So 2:30 if you're in Central Time, and adjust for UK and Eastern European time as necessary. So thanks, Kjeld. Thanks everyone for tuning in, and we'll see you bright and refreshed at 1/2 for the next talks. Ciao.
Thank you. Bye.